morning. This is the math department at Amjad High School, grade 11. This is the second session on antiderivatives. In this session, we'll go over a revision about the previous session, correction of the homework given in session 1. And we will also talk about antiderivatives of linear trigonometric expressions. Starting with the previous session, correction of the homework, exercise 1, calculate the integral of x to the minus 3 plus 2 over x radical x plus 3 over x squared. As we said, before integrating, you have to make sure that the integrand or the quantity which is inside the integral is well written. By the way, x to the power minus 3 is ready to be integrated, but what about 2 over x radical x? It's a fraction, there is a product in the denominator. It's not matching one of the basic forms. First, I'm going to split the integral into 3 integrals because we have addition. So now, what about x to the minus 3? Applying the rule, it's x to the n, so it's x to the minus 2 over minus 2. Now, the next one, which is x radical x, actually it's x to the 1 times x to the half, which is x to the 1.5. Getting it up, it will be x to the minus 1.5. And now it's matching x to the n. So you add 1, it will be x to the minus half, and you divide by minus half. Last one is 1 over x squared. By the way, this is a standard function. You can write the answer directly. Integral of 1 over x squared is minus 1 over x. If you forgot this, you can take x squared up. It will be x to the minus 2, matching x to the n. Then you add 1 and you divide, you will get the same answer. Now, this is the most simplified answer. Next, integral of t squared minus 2 all squared over t squared. Again, this integrand is not matching any of the basic forms. What we need to do here, we need to work on the form. We need to rewrite the integrand in an appropriate form which is ready to be integrated. How? By expanding the numerator, then by splitting. T4 over t squared is t squared, minus 4t squared over t squared is 4, and 4 over t squared. Now you are integrating 3 parts. Each of them is easy to be integrated. T to the 2 is t3 over 3, minus 4 is minus 4t. Again, 1 over t squared is a rule. It's minus 1 over t. So it's minus 4 over t multiplied by this constant. In exercise 2, I'm asking you to verify that on 0 plus infinity, the function defined by capital H of x 2 over 3 into x radical x minus 3 is an antiderivative of the function f defined by f of x is radical x. Actually, to prove that a certain function is an antiderivative of another function, it's enough to derive this function and to get that small f of x. Now, to find the derivative, this function is nothing but u times v, x times radical x. 2 over 3 is a constant, so it's 1 times radical x plus v prime u. Or you could have written x radical x as x to the power 1.5, and consequently you could have avoided the product rule. In all cases, use whatever method you need and to find the derivative, and simplifying the answer, you will get in the long run radical x, which means that h of x is an antiderivative of radical x. We knew that capital H of x is 2 over 3x radical x minus 3 is an antiderivative of radical x. I'm asking you to deduce the function capital F defined by f of x equals integral of radical x plus 2, verifying f of 1 as 3 over 2. We said that this initial condition helps to find the specific c, because when you integrate, you are getting a infinite set of antiderivatives. But solving for C that satisfies the specific given condition, you will get a specific C and consequently a specific antiderivative. So first of all, since f is the integral of this, I do the integral by splitting radical x. The antiderivative of radical x is simply h of x that we have proven in the previous part, plus 2x plus c. Now h of x is 2 over 3x radical x minus 3 plus 2x plus c. Now the answer will be f of 1 equals 3 over 2. We use this to find the c, which is here by simplifying the calculations, it's 5 over 6. Consequently, the final answer, the antiderivative, the required antiderivative is 2 over 3x radical x minus 3 plus 2x plus 5 over 6. Here we note that the arbitrary constant c can be determined by a given condition. So to find a specific antiderivative, the teacher must give you a certain given, like f of 1 equals to 3 over 2. You calculate c, and actually here you will be finding a specific antiderivative and not the set of all antiderivatives. Application: calculate the antiderivative f of x of the function. I'm saying the antiderivative, so I'm talking about one specific antiderivative of this small f of x minus 4x cubed plus 3x minus 5, satisfying f of 0 equals -3. To find the required antiderivative, we start by finding the integral of f of x. But this will give us the set of all antiderivatives because you will have plus c at the end. So it's minus 4x4 over 4 plus 3x squared over 2 minus 5x plus c. So it's minus x4 plus 3x squared over 2 minus 5x plus c. This is not a specific answer. This is the set of all antiderivatives. But capital F of x that I'm asking you about is satisfying a given condition. We say that this is an initial condition. This is an initial condition. Using this initial condition, f of 0 is -3. Plugging in, you will calculate the value of c. So the antiderivative satisfying the given condition will be minus x4 plus 3x squared over 2 minus 5x minus 3. Exercise 3. Choose the correct answer. What is the integral of ax plus b all to the 4? Notice here, this is not x to the 4. Actually, this is u to the 4 dx. But u, what is remarkable about u here? U is just a linear expression. Could the answer be ax plus b 5 over 5? So the student here, if you choose this answer as if you're dealing with ax plus b as if it's x. But this is not the rule. Is it ax plus b to the 5 over 5a? To be sure about the answer, for sure we're not going to expand here. What if we derive these two answers? The one that gives ax plus b to the 4 will be the correct answer. Let me start by deriving the first possible answer. The derivative of ax plus b all to the 5 over 5 plus c this is u to the 5. So you drop this exponent, it will be 5 ax plus b to the 4 times u prime, which is a. Simplifying, this will be ax plus b all to the 4 times a quantity which is not the same as the integrand here. So this answer is incorrect because its derivative is not the same as the quantity inside. Whereas the derivative of the next suggested answer is, you drop this 5, don't forget here that 1 over 5a is just a constant, keep it outside. Ax plus 5 all to ax plus b all to the 5 is 5 times ax plus b all to the 4 times u prime, which is a. Canceling out these two a's, you will be left with ax plus b all to the 4 because also the 5's will cancel out. Ax plus b to the 4 is exactly the quantity which is inside. So this is the correct answer. So the correct answer is this one. In general, what can we say about the integral of ax plus b to the n? Actually, this is u to the n, where u is linear. We cannot deal with ax plus b as if it's x. We start by saying it's ax plus b to the n plus 1 over n plus 1, but actually you need to divide by a. A represents the slope of this linear expression. If the quantity inside, if u is not linear, you cannot apply this rule. You cannot divide by u prime. A here is not just u prime. It's only because this expression here is linear. So, okay, you do it n plus 1 over n plus 1, and you divide by the slope of the linear expression. So 2x minus 1 all to the 3. Since the 2x minus 1 is a linear expression, we can do it directly. It's 2x minus 1 to the 4 over 4, but we need to divide by 2, which is the slope of the linear expression inside. To make sure that this answer is correct, you may derive, and you will get 2x minus 1 all to the power 3. What about the integral of radical 4x plus 1? Actually, radical 4x plus 1 is 4x plus 1 all to the half, which is a linear expression to the power half. So yes, we apply this same rule by adding 1 to the half. It will be 1.5, and you divide by 1.5, but do not forget the slope of the linear expression. And this is the final answer. So don't forget, here you have to start by rewriting radical 4x plus 1 as 4x plus 1 all to the half. What about the integral of x to the 10 plus 7x minus 2 all to the 10? Now, x to the 10 is simply x 11 over 11. What about 7x minus 2 to the 10? Is it 7x minus 2, 11 over 11, just like this? No, because 7x minus 2 is not the variable x. It's a linear expression of the variable x. So we do it by saying that 7x minus 2 to the 10 will be 7x minus 2, 11 over 11, but times 7 in the denominator. So the final answer will be x 11 over 11 plus 7x minus 2, 11 over 77 plus c. One of the common mistakes, one of the misuse of this formula, whenever the students see u to the n, they will say that the answer will be x squared plus 1 to the 4 over 4 times whatever. This is incorrect. And you can try your answer by deriving your answer. You won't get x squared plus 1 to the 3. X squared plus 1 all to the power 3 is a linear expression. Is not a linear expression, and consequently, you cannot apply this rule here. What shall we do? We have to expand. So here we cannot apply this rule since the expression is not linear. We need to expand the integrand. If you expand, you will get x to the 6 plus 3x to the 4 plus 3x squared plus 1. Now you integrate each part, and it's easy to do this. What about antiderivatives of some trigonometric expressions of sine and cosine, but where the angle is linear? What if the angle is not just simply cosine x? It could be cosine ax plus b. It's simply 1 over a sine ax plus b plus c. This is a rule that you need to know by heart. You know that the integral of cosine x is sine x. So the integral of cosine of a linear expression is sine of this linear expression, but you need to divide by the slope. Similarly for the sine, you know that the integral of sine x is minus cosine x. Now the integral of sine of a linear expression will be minus cosine of the linear expression, but you need to divide by the slope. If the angle inside is not linear, like sine of x cubed plus 2, you don't know and you're not responsible how to calculate these integrals for now. Examples, calculate the following integrals. Sine x over 3. Is x over 3 a linear expression of x? Yes. What is the slope? 1 over 3. So the integral of sine of a linear expression will be minus cosine of this linear expression divided by the slope, which is 1 over 3. Simplifying, you will get minus a 3 cosine x over 3 plus c. What is the integral of cosine 3x? Again, this is a linear expression where a, or the slope, is a 3. So it's 1 over a, 1 over 3, sine 3x. So we're just applying rules. So in general, integral of cosine ax plus b is 1 over a sine ax plus b. Integral of sine ax plus b is minus 1 over a cosine ax plus b. What about this example? Sine x plus 2. Again, this is a linear expression whose slope, whose a is 1. So this is minus 1 over 1 cosine x plus 2, which is minus cosine x plus 2 plus c. What about integral of cosine pi x plus 1? Again, this is a linear expression. So 1 over pi sine pi x plus 1. What about the integral of cosine squared x dx? By the way, if we leave the integrand as cosine squared x dx, actually it's cosine x all squared. It's u squared. Does it match any one of these? For sure not. What shall we do here? Sometimes you should know here that sometimes you need to use some trigonometric formulas. For example, you know that cosine 2x is 2 cosine squared x minus 1. This formula is quite important in integrals. Cosine squared of an angle is half 1 plus cosine double of the angle. So whenever you have cosine squared or sine squared of a certain angle, you need to use this linearization. Actually, we are linearizing. We are transforming a quantity squared into a linear expression without cosine squared or cosine cubed. So replacing cosine squared x by this, which is half, I'm not integrating, I'm just replacing cosine squared x by this expression. Half is constant, get it outside. Now inside the integral, you will get 1 plus cosine 2x. Now the integral of 1 is x. Cosine 2x is cosine of a linear angle, so it's 1 over 2 sine 2x. And this will be the final answer. What about the integral of sine squared x? Similarly, you know that cosine 2x is 1 minus 2 sine squared x. Consequently, sine squared x is half into 1 minus cosine 2x. These are trigonometric formulas that you must know, and you need to use them in such context. So replace sine squared x by half into 1 minus cosine 2x. Now I can integrate this part. It's half into x minus 1 over 2 sine 2x. Okay. And this will be the final answer, half x minus 1 over 4 sine 2x plus c. Application, calculate the derivative of the function defined on R by f of x equals x cosine 2x. This is the first part of the application. To find the derivative, you need to look at the form of the function. This is in the product form, and you know that the derivative of u times v is u prime v plus v prime. U is x, and consequently u prime is 1. V is cosine 2x, cosine u. You know that the derivative of cosine u is minus sine u times u prime. Plugging in, so the derivative will be cosine 2x minus 2x sine 2x. Now, the next question is, deduce a primitive h on R of the function defined by h of x equals x sine 2x. Do not forget here, I'm asking you to deduce. You need to use the result of the previous part. We have f prime of x equals cosine 2x minus 2x sine x. Here is the part that I'm asking you to integrate. So the first thing to do in such problems is to isolate the quantity I'm asking you to integrate. I'm asking you to integrate x sine 2x. Here it is, but isolate it. Write it alone. take it to the left. So 2x sine 2x is nothing but cosine 2x minus f prime of x. Consequently, x sine 2x is half, or divided by 2. Each term is divided by 2. Is half cosine 2x minus half f prime of x. Now I need the integral of this, so I need to integrate the right-hand side. Is the integral of the right-hand side easy? Yes, because the integral of cosine 2x is a formula, and the integral of f prime, this is the easiest possible question. The integral of f prime is a function whose derivative is f prime. That's f. So the integral of x sine 2x is the integral of half cosine 2x minus half the integral of f prime of x. Now the integral of half cosine 2x is half times 1 over a sine ax. And do not forget that the integral of f prime is f. Now replacing f of x by its expression, you will get this final answer. Thank you for this session.